Hello, this is a wireless network design proposal for the Lopes Manufacturing Company. This network will include design elements for both the corporate offices and the manufacturing plant, which is off-site. We will include workarounds for this separation of the corporate office and the manufacturing plant in our design. The The objectives of this network are to provide a secure connection for hundreds of wireless devices simultaneously. This network will utilize several wireless access points to provide redundancy and decent coverage of the entire building. The network will be running with several hundred devices at the same time, working to develop and produce the helicopter parts that Lopes Manufacturing provides to its clients. And this network will be configured to securely send data between the two buildings with the use of VPNs and encryption software to further secure the data. As this is confidential, we don't want that information getting out to the public or getting to people where they really shouldn't have data on our parts. The network will be outfitted with switches with a surplus of Ethernet ports in order to allow for significant expansion if necessary, and this will only require routers and wireless access points to be upgraded over time in order to account for the greater number of devices running on the network. Employees, we expect them to use their work-provided laptops, their tablets, their personal mobile phones, primarily for business purposes, which will require powerful access points that have the range and speed to fulfill those needs of our employees. These devices will require compatibility with the 802.11 AC wireless standard in order to achieve maximum range and data transfer speed. One thing we need to prepare for is the fact that interior walls, the material of the building itself, could affect signal strength, which means we will need to have supplementary access points to overlap with our central access points in order to ensure 100% coverage. This could be having coverage in restrooms, in offices that have sealed doors, in break rooms, places that are off from the main drag in the building. For our equipment needs, we'll definitely need new routers, wireless access points. We will need to add switches in order to have the ability to expand in the future. On top of all these costs, we're expecting a budget of around $45,000 to $50,000 in order to purchase and install the new hardware for parts and labor cost. The network will be sending basic office-related files, PowerPoint presentations, spreadsheets, Word documents, modeling files for 3D printers and CNC machines. This is more the manufacturing side, but it can also apply to the engineering team in the corporate office. And because of these secure CAD files for 3D printers and CNC machines, we will need more robust security hardware in order to ensure that these files are secure and they are not compromised from being sent back and forth. We'll need to support a minimum of 300 to 400 devices at launch of the network running simultaneously. And again, we are assuming that we're going to be growing in the future, so we're going to have a little bit of wiggle room at the beginning with easy room to grow when the company does end up growing. Speed requirements, we're expecting with a cable connection, minimum 100 megabits per second download with 20 megabits upload, and we're expecting pretty light loads for normal office operations on the network. The primary load on the network will be originating from the manufacturing facility due to how much network traffic goes on between the manufacturing personnel, the CNC machines, 3D printers. During peak hours, the load will be considerable, which is why we'll need more powerful hardware to compensate for that, despite having a lower number of devices accessing the network simultaneously. We're expecting the network to be reliable enough that users will be able to connect consistently with no unexpected slowdowns or disconnections. In order to combat this, despite entire, say, an ISP disconnecting from us temporarily, we're going to be providing redundant access points, switches, and routers, so that way the reserve hardware can take over until the piece of hardware that is malfunctioning is repaired or replaced. Routers will be configured to only allow specific ports to act as wireless access points, and this will prevent employees from installing their own switches or routers on the network, which can act as a security breach. We will be utilizing software similar to Active Directory in order to restrict users from what they can and cannot access on the network. This will include blocking websites, blocking download files from unapproved domains, and we will block using personal storage devices to import personal files or export company files. Along with standard encryption, probably WPA, between devices in order to further secure the files. For the actual materials needed for the proposal, we have a few devices picked out. We have a Cisco wireless LAN controller. This is the most expensive individual piece of the network, but it is the most important. This guy runs in just under $3,000. They support up to 100 wireless access points simultaneously, and they have a limited 90-day warranty on their parts and labor. Connecting to the wireless network controller, we have the Cisco wireless access points. These go for about $750 a piece and can provide data speeds of up to 300 megabits per second over 802.11a, b, g, and n channels. They also have a lifetime warranty for their parts and labor. In order to secure all of our files on the network, we will be utilizing sonic wall firewalls. These guys are our primary security measure on top of all the security measures installed on the routers themselves. These guys go for about $220 a piece, and they include DPI software, anti-malware software, and they have compatibility for site-to-site VPN tunnels and VLAN support for entire networks. This is important for us as it allows us to securely send data from our corporate office to the folks over in the manufacturing facility. In central locations, we will have bulk switches. We have selected Cisco 48-port smart managed switches. These act as almost a router of sorts, gives us a little bit, gives you a little bit less load on the router itself. This guy goes for $928 per unit, and it has 48 gigabit compatible Ethernet ports with smart management firmware. These guys also have a lifetime warranty for their parts and labor. For our modem, which will convert the cable signal to an Ethernet signal on the network, we have chosen a Motorola DOCSIS cable modem. This is compatible with most major internet service providers, including the one we're going to be going with today. These guys go for $169.99 and is capable of download speeds up to 3.8 gigabits per second and upload speeds of 1 gigabit per second. These guys include a 2-year limited warranty on parts and labor. And then finally, for more densely populated areas, places we're going to want VPNs, more secure, smaller networks for, like, say, the engineering team or the quality assurance team or our executive team, we have these D-Link unmanaged 8-port gigabit switches. These guys have 8 gigabit Ethernet ports, have a lifetime warranty on their parts and labor, are about $25 a piece, and will allow multiple end devices to connect to create a more secure subsection of the network where these computers, say one engineer can quickly send one file from his computer to the computer of another engineer's without basically going into the main section of the network that has the router and our primary 48-port switches. These are also designed to take the main load off of the 48-port switches and the routers. Cost analysis, we're looking at about $23,000 to $25,000 for all of the components of the network, alongside an expected $15,000 cost for labor and any additional unexpected expenses. If there's a delay in the installation, if there's a part that is broken out of the box and needs to be replaced, if there's an additional part that we didn't consider that we need, that would be where the funds for that part would come from. Testing the network, we will require mobile devices, more than likely a smartphone or a tablet running the Android operating system. These will be installed with network monitoring tools one of which is known as Network Monitor. And this software is used to determine interference on different channels of a network and the signal strength of a particular network. What we will do with these is we will have the devices connected to our wireless network, and we will physically go to the edges of the network coverage where we can maintain a stable connection and determine if we need to install another access point to further extend the range of the network. The speed of the network will be determined by downloading large files off of the internet. These will probably be high quality video files or high quality photos, something that is a very dense file data wise. And that will determine our network speed from our ISP to our network. We will also use large files, likely CAD files, 3D printer files. We will send them from computer to computer over the internal network in order to test the speed from computer to computer without having to go through the primary router, without sending files over the network. And of course we will also do this with the site-to-site VPN tunnel in order to test the speed from the corporate network and sending that data over to the manufacturing network.